If you remember back to our solving rational equations, we ended up with solutions that we couldn't use because we would plug those solutions back in and we would end up dividing by 0. Those were our extraneous solutions. We're going to run into the same issue with logs. So let's take a look here. So as I go forward, I'm just going to solve this log like normal. So addition means I'm going to condense using multiplication. So I'm going to get x squared plus 6x, x times 6 equals 1. Because I have a log equaling a number, I'm going to rewrite this as an exponential. So 7 to the first equals x squared plus 6x. Since it's a quadratic and I have my linear term, I'm going to set this equal to 0 so I can solve by factoring. So my factors of 7 are 7 and 1. It's got to equal a positive 6, so that's a plus 7 and a negative 1. My factors are x plus 7 times x minus 1. So that tells me my solutions are negative 7 and 1. But we're going to have an issue here. And the issue is with my negative 7. If I take my negative 7 and I plug it in right here, log base 7 of negative 7. If you remember what a log means, this is saying 7 to what power equals negative 7. 7, I've said that word a lot. How many times can I multiply 7 to itself and it's going to turn negative? Never. You cannot take the log or evaluate a log of a negative number. So after I plug this in, so even here, negative 7 plus 6, that's a negative 1. I can't take the log of a negative number. So negative 7 here is an example of an extraneous solution. Algebraically, we found it, but we plug it back in, and it doesn't satisfy the equation. It doesn't work. Okay? So when we're taking any log base a of x, x has to be greater than 0. In other words, we can only evaluate a positive number. And yes, that means we can't take the log of 0 either. 7 to what power equals 0? Not going to happen. Okay. So, similar problem here, but except now we're subtracting, so that means division. So this is going to be log base 4 of x divided by x plus 5 equals log base 4 of 35. We have a log equaling a log, so we can evaluate the x divided by x plus 5 equals 35. Because we have an x in the denominator here, we're going to go ahead and multiply both sides by x plus 5. And that's going to give me x equals 35x and 35 times 5. So that's 175. Okay. So I have two x's, so I'm going to combine like terms by minusing my 35x over. That's negative 34x equals 175, and I divide by negative 34. So x equals 175 divided by negative 34. We have one answer. But wait, this is a negative number. If I plug it into my original function, I'm taking the log of a negative. But it's my only answer, and it doesn't work. This doesn't work. So for this problem, there is no solution. Excuse me. Sorry about that. Okay. Extraneous solutions. Always check your answers. Make sure they work. Good luck.